I love the police. All right. All right, here's the first example. It says Sam invests $7,500. And this is at 7.75% interest, compounded quarterly. And then the question is, how much will he have after 3 years? It's quiet because everyone's focusing. So Sam invests $7,500 at 7.75% interest, compounded quarterly. How much will he have after 3 years? So what is the key word in this problem that helps us figure out the formula? Compounded, that's a key word. So we have two formulas that have compound in them. Which one are we using? Compound interest. And what word tells us to use compound interest? Not well yeah. But so compounded continuously, it could say the interest was compounded continuously. It could have the word interest as well. So what's the other thing that helps us know it's this problem instead? The word quarterly, yeah, they're telling you the n value. N is the number of times per year. How many times per year is quarterly? 4 times per year. So compounded quarterly, those are the two words that help us figure out which formula we are using. Okay. So we're going to write down our formula. That is y equals P, and then we've got 1 plus R over N to the NT. So we're just going to start off making sure we know what each of the letters represents. So did they tell us what the y value should be? Did they give you a final amount? Yeah, no, there's no y value here. That's actually what we're solving for. Like, how much is the final amount? Did they give us a p value? Yes. What is it? Yes, 7,500, right? 1 less 0. Did they give us an r value? Yes. Yeah, what is it? So 7.75%, we can't actually use that number. What do we actually use? 0.0775. So we take this decimal point and we move it 2 places to the left. Did they give us an n value? Yes. Yes. For quarterly. 4. In your notes, you might write the word quarterly so you remember where that came from, since it's not written as a number in the problem. And then did they give us a t value? Yeah. 3 years. Okay. So we can go ahead and write all that information out. We've got 7,500. 1 plus 0.0775 divided by 4. And then n times t would be 4 times 3. And if you're using a school calculator or you have one of the newer calculators that kind of looks like this, then you can type it in to look exactly like that, which is kind of nice. And I want to hear everyone typing because all of us want to make sure that we know how to plug these into our calculators. It should look like that. Why am I putting a squiggly sign? I'm going to round. I'm about to round my answer. All right, so what are we getting? So 9,442 point, how many decimal places should we have? 2. Why is it 2? It's money. Yeah, it's money. Point, what should our 2 decimal places be? 11. Good. When I write this answer in a sentence, is it appropriate to still have a decimal answer? Yes. Yep. So we're going to say, he will have, Sam will have. And then we either have to put a dollar sign in front of the number, or we have to put the word dollars after the number. So whichever you choose to do is fine by me, but we got to have some units in there. I've gotten a lot of text messages past minute. Okay. Oh yeah, we'll have about $9,442.11 after 3 years. For that same scenario, we're going to ask another question. We're going to say, how long until he doubles his investment? How long until he doubles his investment?
That's 7,500 times.
So what is the variable we're solving for this time? T. And we know that we're solving for t because they asked the question how long, and t is the variable that represents time. So t is what we are asking. Now the issue that students typically have with when they don't give us the actual amount and they say like double the investment or triple the investment is if you should double this number right here, or if you should double this number from the beginning. So which one of these represents the investment that he made? The beginning number. So that's the number that we're doubling. The 9,442 is what he had after 3 years. That's not what they're asking us to double. They're asking us to double his original investment. So we're going to go ahead and say that y equals whatever the double amount is. So what happens when you double 7,500? Yeah, 15,000. Okay. And is there any reason for the rest of the information to have changed? Did we change our initial value, about 7,500? Did we change it? No. Did they tell us to change the rate? Did they tell us to change that it's compounded quarterly? Nope. So the rest of it's going to stay the same. We're just going to say 15,000 equals 7,500 times 1 plus 0.0775 over 4 to the 4t. So we're just not plugging into 3 this time. So what's the first thing we could move away from t? Yeah, 7,500. And what do we get? Yeah, 2. Why did we get 2? Because you just doubled it, yeah. So if we had tripled it, then what would it have equaled over here? 3, yep. What if we had quadrupled it? What would have equaled over here? 4, yeah. So if you double or triple something, it's just going to end up equaling that number when you do it over there. And then we've got our parentheses, 1 plus 0.0775 over 4 to the 4t. Is there anything else we can move away from t with the way it looks right now?
No.
No. So we have an exponent we can't get to. So how do we undo that exponential form? Log form. What's the base of the log?
1.07.
Yeah, it's whatever this would happen to be, right? It's that whole parenthesis. So this whole parenthesis is the base of the exponent. So that whole parenthesis becomes the base of the log. And you can put it in parentheses if you want. If you have a newer calculator, your calculator will automatically make that whole thing the base as you type it in, so it technically doesn't need parentheses when you type it. What comes next? The 2, yep. So we Tootsie Roll, we go around, so the 2 comes next. What comes after that? 40. Okay. Are we done? No, what should we do? Divide by 4. And you can type it in to look just like this. So we've got log . Do you guys see how similar these are to what we did yesterday? Yeah. So that's kind of the nice thing about this is they're very consistent. The same numbers go in the same sort of place. Solving it works out the same way each time. And what are you guys getting for your time? 9. So we have 9 point. We'll do 2 decimal places. So what would it be? 0.03. And what are the units for this? Years, yeah. So when we do these problems, our default, time frame is usually in years, unless the problem specifically uses a different measurement. We typically are going to say years in this. So let's go ahead and write it as a sentence. It will take him about 9.03 years to double his investment.
We divided the 7,500 because it's multiplied by the parentheses, right?
Yes. So this operation right here, when they're written right next to each other, it means multiply. So to undo it, you divide. Yeah. Any other questions? You guys ready for the next one? What? 2 examples? I'm so excited.
Oh, no. I'm not singing. I'm not. What?
She's excited. You're excited, right, Deja? You're going to sing because you're excited?
Not yet. Oh, no. I mean,
Binary.
Sorry, just other people.
All right. We ready for the next one?
Yeah.
All right. Sarah deposits $1,000.
What is that? Is it Sweden?
It's like hail. Little
Did you know that the zoo closes 2 hours early today because it's sleeting? It does. Mr. Rigsby told us that.
They're keeping the animals
So we get out at 2 o'clock.
The zoo.
Girl, you don't want to get on at 2 o'clock.
I mean, Northern is pretty close to a zoo.
That's what you said.
I mean,
Go ahead and eat an animal. Let's go.
So Sarah deposits $1,000 into an account paying 3.8% interest.
It ain't ghost. It's
really not.
Compounded continuously.
I hope you get hit by one.
Hey guys, there's a lot of talking going on. It was me. All right, so her interest is compounding continuously, and we want to know how much money she has after 5 years.
Is this decreasing because she's paid?
She deposits the money into a bank account, so she is getting money.
Okay.
Yeah, she's being paid. We know all about that, right? Mm-hmm. Yes, sir.
What does compounded like continuously quarterly?
So compounded quarterly means that like every 3 months your interest would be tallied up and given to you. Compounded monthly would be like every month they look at how much money you have and they give you the interest. Compounded, it means it's like based off of the money that's in the account at that time. So yearly would be like once a year they look at that's how much money you've got in there. We'll give you this much interest based off how much money you have at this one time every single year. Like every May 5th, we look at the amount you have and we do the interest. Compounded quarterly would mean that like maybe on the 5th of every 3rd month they do it.
So is compounded type of interest?
It's like the method of how you would get the interest, like the calculations. Yeah. Okay. So compounded continuously means that they are monitoring your account every day, and that's how it's like getting the interest. You're constantly getting it. Every little change to your account is going to reflect some sort of interest change. All right. So, what wording in the question tells us which formula to use? Yeah, compounded continuously tells us to use the compounded continuously formula. How nice.
It also said interest.
Huh? So they're looking at the amount you have in your account at all times. They are constantly looking. So no, this is like daily. This is like all the time. They're looking at the changes to your account. So for this equation, we do not have an end value because it's compounded continuously. It tells us to use a different formula. All right. Hey guys, we're a little chatty. I still like you, but we're a little chatty. Sometimes people call this equation Pert. Why do you think they call it that? Because it literally says Pert. All right, did they give us the final amount? Now that's what we're trying to find, right? Is how much we have at the end. Did they give us an initial value? Yes, what is it? 1,000. Did they give us an E value? Yeah, that's the calculator button. I tricked you guys. Calculator. Button on your calculator. Did they give us an R value? Yeah, what is it? It's 3.8%. How do we write that as a decimal? So 0.038. Did they give us a time frame?
5 years.
5 years. All right. So at this point, we are ready to plug this in. We're going to say y equals 1,000 e to the r times t. Real rough, right?
So we have to remember these formulas.
On the test, I'll actually tell you which formula to use.
Okay, good.
The reason I'm explaining it to you every time is I want you guys to start to get an idea of how you could figure out which formula, so that in the future, if you didn't know, you could figure it out. It's not too bad to figure out which one to use. All right. Is a button on your calculator. All right, let's go ahead and type it in. We got 1,000. I mean, you don't know how good the microphone is. So second LN to get the E button. Yep. Okay. All right, and so I'm going to say y is approximately 1209. What decimals should I put? 25. What are the units on this number? It's money, so it's dollars.
Oh, that's me and Erica's birthday right there.
December 9th?
Yeah.
I got you. From 1925?
Oh, no.
No?
No, I don't think so.
Okay.
Oh, it's not your birthday tomorrow? Oh, it's not your birthday tomorrow. Happy birthday.
Girl, what's you on the beach?
You guys are real antsy today. All right, she has... goodness gracious. She has about $1,209.25 in the account after 5 years.
You cannot be talking.
If I was born in 1925, I'd be like 80 something, right?
You won't. You did. Oh, let's see what it says. I mean, we're 10 years old, but...
All right, the next question we're going to ask is how long will it take the account to reach $2,000?
You'll be 92.
She already said that.
Oh, I just calculated. She announced it to the world.
I mean, I didn't really announce it. I just put it up on the screen silently. All right, so which variable are we solving for this time? Which variable are we using this time to solve? Time. How long? We're solving for t. Did they give us the end amount then? Yep. Y equals 2,000. Is there any reason the other number should have changed? Nope. So we're going to say 2,000 at the end equals the beginning amount times e to the r t. So what do we do next? You divide. Divide by what? 1,000. And you're right, yep. 2,000 divided by 1,000 equals 2. And then we should divide by e, right? Wrong. Yeah. We're going to do a log, and I hear lots of people saying ln. Why are people saying ln? But yeah, we're about to have a log with a base of e. So log base e of what? 2, yeah. It's written backwards from what we were doing before, right? When we were converting the forms. So log base e of 2 equals... Are you like waiting for someone to come get your pen? Yeah. Jason, don't do that. What are you doing?
Thank you.
You make her get her own pen.
I'm too comfortable with my legs crossed.
All right, log base e of 2 equals what? All right, are we done?
No.
What should we do? Divide by 0.038. Yeah. So I keep hearing people say ln. What do you mean with the ln? What should we write? ln2. Yeah, this log base e. This log base e can be rewritten as ln. So I'm going to say this is ln2 divided by 0.038. Are you going to get it wrong if you leave it as log base e? No, it's the same thing. People are just going to look at you funny because nobody really writes log base e. Everyone writes ln. So we're going to hit the ln button, ln2 divided by 0.038. So how much time did it take? 18 point... 2, 4, what are the units? Years.
Do I do ln2 divided by ln?
No, you would do ln2 just divided by 0.038. The reason you're not typing it twice is because, first of all, you're using the ln button, so you wouldn't have to because you're not changing a base. But second of all, because that 0.038 is not the base in the log. That's why you can just type it in as ln. So it would take
About.
all right. Woo.